Imagine machines that can think and learn just like us. That's the idea behind artificial intelligence, or AI for short. This idea has been around for ages, even popping up in old stories and myths. But it wasn't until the 1940s, when computers were born, that AI started to feel real. Back then, computers were already amazing at doing math really fast. But scientists wondered if they could do more than just calculations. Could they actually learn to think like humans? This is when some really smart people started figuring out how to make computers process information, make choices, and even learn a little bit. It was like setting the stage for a big change, and one of the stars of this show was a brilliant British mathematician named Alan Turing. Alan Turing was a genius, a visionary whose work laid the foundation for modern computing and artificial intelligence. Born in 1912, Turing's early fascination with numbers and patterns set him on a path that would change the world. He was a mathematician, logician, and cryptanalyst who helped shape the world of AI. His contributions during World War II, particularly in breaking the Enigma code, were pivotal in the Allied victory. But Turing's work went beyond just computers. He was deeply interested in the concept of machine intelligence. He pondered the question, can machines think? This question drove much of his research and led to groundbreaking ideas. In 1950, Turing wrote a famous paper titled Computing Machinery and Intelligence, where he introduced something called the Turing test. This test was designed to determine if a machine could exhibit intelligent behavior indistinguishable from that of a human. The Turing test was a thought experiment, like a puzzle in your mind. It challenged the very notion of intelligence and forced people to reconsider what it means to think. Imagine talking to a computer and a person, but you don't know which one is which. If you can't tell who's the computer and who's the human just by talking to them, then Turing thought, maybe the computer is actually thinking. This idea was revolutionary. It got people talking and arguing, but it also gave scientists a goal. They wanted to build machines that could trick you into thinking they were human. The Turing test became a benchmark for artificial intelligence, pushing researchers to explore the boundaries of machine learning and cognitive science. It wasn't just about creating smarter machines. It was about understanding the nature of intelligence itself. Scientists and engineers were inspired by Turing's vision. They wanted to build machines that could learn, adapt, and understand the world like humans do. This dream led to the development of neural networks, machine learning algorithms, and other AI technologies that we see today. Turing's dream wasn't just about building calculators. He wanted machines that could learn, change, and understand the world like we do. His ideas laid the groundwork for the AI revolution, influencing countless researchers and innovators. But Turing did more than just think about the future. He was a practical problem solver who applied his theories to real-world challenges. During World War II, he played a crucial role in cracking the Enigma code, a feat that saved countless lives and demonstrated the power of computational thinking. His work during the war showed how powerful computers could be, not just as tools for calculation, but as instruments of strategic importance. Turing's contributions to cryptography were as significant as his theoretical work on AI. Sadly, his life was cut short, but his ideas about AI still inspire people today. Turing's legacy lives on in the fields of computer science, artificial intelligence, and beyond. His vision of intelligent machines continues to drive innovation and challenge our understanding of what it means to be human. The 1950s was a time of excitement for AI. It was a decade marked by rapid technological advancements and a sense of boundless possibilities. Scientists and researchers were diving into uncharted territories, exploring the potential of machines to mimic human intelligence. It felt like anything was possible. The air was thick with anticipation and the promise of groundbreaking discoveries. Every new development was a step closer to a future where machines could think and learn like humans. This was when the term artificial intelligence was invented, giving a name to this incredible new field. The concept of AI captured the imagination of scientists and the public alike, sparking a wave of enthusiasm and curiosity. In 1956, a bunch of brilliant scientists got together at a place called Dartmouth. This historic meeting, known as the Dartmouth Workshop, is often considered the birthplace of AI as a formal academic discipline. They wanted to see if they could build machines that could really think. Their goal was ambitious: to create systems that could perform tasks requiring human-like intelligence, such as reasoning, learning, and problem-solving. This meeting was like a spark that lit a fire of research and new ideas. It ignited a passion for AI that would drive decades of innovation and exploration. The discussions and collaborations that took place at Dartmouth set the stage for the future of AI. Scientists were super optimistic back then. They believed that with enough time and effort, they could unlock the secrets of human intelligence and replicate it in machines. This optimism fueled a surge of creativity and experimentation. They made programs that could play games, solve puzzles, and even perform tasks that seemed to require a degree of understanding and reasoning, and even have simple conversations. These early AI programs were rudimentary by today's standards, but they represented significant milestones in the journey toward intelligent machines. It felt like we were on the verge of creating super smart machines. The excitement was palpable, and the possibilities seemed endless. People envisioned a future where AI could revolutionize every aspect of life. One famous project was the General Problem Solver. This ambitious initiative aimed to create a program that could solve a wide range of problems, mimicking the versatility and adaptability of human thought. It was designed to solve problems like a human would. The General Problem Solver was a testament to the bold vision and innovative spirit of the early AI pioneers. But as time went on, scientists realized that copying the human brain was way harder than they thought. The complexity of human cognition presented challenges that were far greater than anticipated, leading to a deeper appreciation of the intricacies of intelligence. Section 4. The AI Winter, a period of dormancy. Remember all that excitement about AI in the 1950s? Well, by the 1970s things had cooled down. This time is called the AI Winter. It was like the field went into hibernation. Why did this happen? Well, those big dreams of super smart machines hadn't come true yet. Building AI was much harder than expected. Computers weren't powerful enough, and we didn't fully understand how our own brains worked. Early AI programs could do some cool tricks, but they weren't very smart overall. They couldn't handle new situations or learn from their mistakes very well. But even though it was a tough time for AI, some dedicated scientists kept working. They knew AI had potential, and they were determined to figure it out. Section 5. Rekindling the Flame. AI's Resurgence. As the 1980s turned into the 1990s, AI started to wake up from its long nap. The era was marked by a renewed interest in artificial intelligence, driven by advancements in computing power and the availability of vast amounts of data. Researchers began to explore new algorithms and techniques, hoping to push the boundaries of what machines could achieve. Computers were getting faster, we had more data than ever, and scientists had new ideas. The combination of these factors created a fertile ground for innovation. Researchers were no longer limited by the slow processing speeds of earlier machines. They could now run complex simulations and experiments that were previously impossible. One big moment was in 1997 when a computer called Deep Blue beat a chess champion named Garry Kasparov. This event was a watershed moment in the history of AI, demonstrating that machines could outperform humans in specific tasks. It wasn't just a victory in a game, it was a symbol of the potential of AI. Deep Blue showed that computers could be incredibly good at solving complex problems. The victory over Kasparov was a clear indication that AI had the potential to tackle challenges that required strategic thinking and planning. It opened the door to new possibilities and inspired a generation of researchers to dream bigger. But AI was more than just playing games. The technology had far-reaching implications beyond the realm of entertainment. Researchers began to explore how AI could be applied to solve real-world problems, from healthcare to finance, and even environmental conservation. Scientists were developing machine learning, which meant teaching computers to learn from data. This was a significant shift from traditional programming, where machines followed explicit instructions. With machine learning, computers could analyze patterns and make decisions based on the data they processed. This led to breakthroughs in understanding speech, recognizing images, and even translating languages. These advancements made AI more accessible and useful in everyday life. Voice assistants, image search engines, and translation apps became increasingly common, changing the way people interacted with technology. Big companies like Google and Amazon saw how important AI was and started investing a lot of money in it. They recognized the potential of AI to revolutionize industries and create new business opportunities. Their investments accelerated the development of AI technologies and brought them to the mainstream. Governments also supported AI research. They understood that AI could drive economic growth and improve public services. Funding and policy initiatives were put in place to encourage innovation and ensure that the benefits of AI were widely distributed. All of this led to a surge in progress, and today, AI is everywhere. From smart home devices to autonomous vehicles, AI has become an integral part of our daily lives. The journey from the early days of AI to its current ubiquity is a testament to the relentless pursuit of knowledge and innovation by scientists and engineers around the world.